They'll pick it up, and that's good stuff because the good responses makes you look that much better. So today we're talking about transformations of linear functions. In Algebra 1 and Algebra 2, there is a very common theme. And that is that every major family of equations you study has what's called the parent function. This is the function that all other functions in that family spring from. For linear equations, the parent function is the one we see over here on the left in our notes that says f of x equals x. This line is like the basic. It's the original OG straight line graph. F of x equals x. It goes perfectly right through the middle. It goes up 1 over 1. It's a nice, perfectly straight and cuts your grid in half diagonally. Now you can add numbers, subtract numbers to it, multiply numbers, divide numbers to it, and get all kinds of different effects to the line. You can make it move left, right. You can make it move up and down. You can make it get more steep or more flat. You can do all kinds of things. You can even make it flip directions if you negate it. And we're going to practice, and we're going to learn what different operations do to our line. Or in other words, we're going to transform it. We're going to be comparing our y-intercepts to make our decisions and looking at slopes. And then we will have an example of a reflection coming on this lesson. But our best bet is just to jump right into it. Now, we're going to be making some small tables, so do not write too terribly big when we start doing this. So in our grid here on the bottom, we have this, on my screen it's a red line, on yours it's just a black and white. This is the parent function. So this is the one we're going to compare everything to. This parent function has a y-intercept at what point? At 0. So I'm going to put a point there. This is how we're going to compare all our other graphs. We're going to see where that dot moves as we make these other lines. Are you asking a question?
No.
What's your question?
I was going to say no.
Oh, okay. All right, well, I'm going on then. Not sure what that was about. So let's go ahead and make a table. Here's how we're going to make our table. I'm going to make it going horizontal. Only 4 little columns. And x will be on top, y will be on the bottom. I'm even going to give you the numbers we're going to use for this. We're going to plug in for x a -1, a 0, and a +1. Because we're working with straight lines, all you need really is 2 good points, but we'll just use 3 for good measure. So make sure everyone's writing this table down on their notes, right? Okay, so you should be writing this down. There you go. That's how the paper usually faces when we're writing. Now, our function says take whatever your x value is and add 4. My first x value is -1. What is -1 plus 4? 3. My second x value is a 0. What is 0 plus 4? Yeah. And then my third x value is this +1. What is 1 plus 4? 5. So I'm going to graph these points. My first point is at -1, 3. So from the origin, I go left 1, up 3, and make a dot. My second point is at 0, 4. So from the origin, I go 0 left or right, which means I don't go left or right, but I just go straight up 4 and put a dot there. My third point in my table is 1, 5. So I go +1 space to the right of the origin and up 5. Do we now have enough points to make a straight line? So with your IDs, your ruler or whatever, make your straight line. I'm going to fill in all the other points just for my graph so I can make it look nice and practically perfect. All right, so I'll go ahead and get my marker a little thicker. I'm going to go ahead and connect all my dots. Making sure to put arrow tips on the end of my line. And since this is our first example, A, I'm going to go ahead and just label this line A. Any questions about what I did, the physical process of making the line? Are we okay so far? All we did was graph a line, correct? Now let's compare this blue line that I drew to the red one we had originally, and we're going to use the y-intercept as a comparison. So in our first original parent line, the y-intercept was down here at 0. Now where is the y-intercept in that blue line? Say it again. On the y or x-axis? On the y. So How did it move? To get from this point here to this point here, how did the line move? Up how many squares? 4. So here's how we're going to explain the transformation. Right here in this little space, graph A, which is this blue one we just did, shifted 4 units up. So the effect we have is when you have an x in your equation and you add 4 after it, it moves it 4 units up. That's the effect. So adding 4 or adding anything after the x makes it move up. So that takes me to my second example. Here, for example B, I have x minus 5. What do you predict might happen to that line? If plus 4 made it move 4 squares up, what would minus 5 do? Prediction? That's one prediction. What's over here? I hear 5 squares down. Anything different than those two? I hear possibly negative or possibly 5 squares down. So let's try this again with our new one. I'm going to switch up colors. So those of you who are using different colors, here's your chance to mix it up a bit. So let's do line B. We're going to make the same type of table again. X's and Y's. I only need 3 good points. And I'm going to use -1, 0, and 1 again also for my x values. The rule for this second line says to take your x value and subtract 5. So whatever x is, minus 5. What's -1 minus 5 more? -6. What's 0 minus 5? And what is 1 minus 5? And you should see a pattern with these straight lines with your answers, like -6, -5, -4. Going before with 3, 4, 5. So let's graph these points. Starting from the origin, my first point in green is going to be -1, -6. That means left 1, down 6. I need a little more room right here. My second point from my table is going to be at 0, -5. So I don't move left or right, I just go down to -5. My third point from my table is at +1, -4. So I go +1 to the right and -4 down. I now have enough points to go ahead and make a line. I'm going to go ahead and fill in the rest of the points just for the sake of clarity. Then I will connect all my dots to make my solid line. So far in this process, are there any questions or points of confusion? Or is everyone okay so far?
Okay.
Yes. Ask away.
So is it all the time gonna be like the same number?
For the x values?
Yes.
Those are good standard ones to use. It's always good to have at least one negative number, a positive number, and 0. These are the equal points, because things always happen around that area. And they're the easiest numbers to do mathematically. Adding ones, subtracting ones, always easy to maybe pick like -17, 35. The bigger you get, the harder the math you get sometimes.
So and it's also like division.
If it's in the equation, so far we've only had addition up here and subtraction down here so far. But all operations are up for play. But we're going to just do one thing at a time right now, so don't panic yet. I got you. All right, so let's look at our y-intercept and make a comparison. Our y-intercept now is down here. So the parent function begins right here at 0. This new line, how did it shift? 5 units down. That's exactly the prediction. 2 of you out of the 3 of you predicted that, and you 2 were absolutely right. So the transformation that happened was that the original parent line has now been shifted 5 units down. So apparently, adding a number after x makes your line move up. Subtracting a number after x makes your line move down. Now look at our third example. Are we adding or subtracting anything on C? No. But what makes C different? What fundamentally is different about graph C? There's one symbol in there. The X is in all of them.
And
What's in front of the X?
parentheses.
In front of the X.
Oh, negative.
A negative sign. So this kind of goes to where Jada was thinking, what do you think a negative sign will do to our line?
Oh, it's the shade.
Say it again.
The
Opposite direction. So right now it's from left to right. It's increasing or decreasing. So our predictions, and you guys are not off at all, it's going to go decreasing. So let's double check and see if that indeed happens.
It's negative.
Yeah, that's exactly right, dude. You said it's negative, so it should have a negative downward slope. I'll go ahead and switch out to this color. Let's follow the process again. Make your table. Make enough. Make 3 columns in there. Let's use -1, 0, and 1 again. And then we'll talk out how to get our y values. So really, with this equation for c, we have an invisible -1 being multiplied times x. Do you understand that? Because we have those, it's one of those negative, it's one of those invisible numbers. So let me ask you this. What would -1 times -1 be? What would -1 times 0 be? What would -1 times +1 be? Let's graph those points. So -1, +1. From the origin, I go left 1, up 1, and then make my point right there. I go through the origin at 0, 0. So I did the first point. I just did my second point. My third point is at 1, -1, right 1, down 1. And the prediction that my students made, and we have it on camera, was absolutely correct. You guys said it would be going downwards because it's a negative, which means it has a negative slope. So it indeed switches from a positive direction to a negative direction. So we'll... Yes, that is actually really good. If you remember that. Proportionals are only lines that go through the origin. So yes, it is proportional. So we're going to say that but what's the big difference from the original one to the new one? Is that the direction change from being positive to negative. So we'll just say the transformation that happened was the slope turns negative. All right, so to recap, adding numbers at the end makes your graph move up. Subtracting numbers at the end makes your graph move down. Multiplying times -1 makes your slope become the opposite, in this case, negative. Predictions. What would multiplying times 1/2 do to your line?
And it's gonna, well, if it's positive, it's gonna increase it by 1/2, but it's negative.
So it is positive. It's positive 1/2. So if my parent line is this perfect line that goes to the middle and all nice and neat, what visual effect do you think might happen when you multiply times 1/2? Do you think we're going to get a movement like up, down, left, right? Will it become negated? Will its slope change? Or do you think it might get steeper or flatter? That's another transformation too. So I have a prediction. I have someone saying flatter. Anyone want to propose another prediction? What? Only one person's brave enough. All right, let's compare and see what she gets, if she's right or wrong. So I'll go ahead and change the color out. And thank you, by the way, for just being brave enough to give me a prediction. So let's go ahead and make a table again. Same exact points. -1, 0, and 1. Multiplying times half just means cutting it in half. So let me ask you this. What is half of -1? -1/2, no? Right? Half of -1 is -1/2. What's half of 0? 0. And what's half of +1? +1/2. So let's graph this point. At -1/2 and -1/2, so I go back or left 1 square, but I only go down half a square. So this point's floating. My next point is now at 0, 0, the origin. That one, a lot of the lines have gone through. And then my third point is at 1, 1/2. So right 1, up 1/2. I don't understand what you mean by you can't find it.
It's negative 1 and
Yes, so you go -1 square to the left and half a square down. So now, compared to what Jada said, she said that she predicted it would be flatter, correct, Jada? Are you right or wrong? No, you're not. You are absolutely right.
Oh.
It went from this to now it's going this now, a little more flatter. So multiplying by a fraction makes it flat. Multiplying by fraction made it flatter. Yes.
Will it also turn into like a zero?
What do you mean by turn into a zero?
If we keep multiplying by fractions,
It can, it depends on the fraction. If you pick a sufficiently small enough fraction, it'll look almost like a flat line. But the only way you get the perfectly flat line is if you have the number 0. That's really good. That's really good connections you're making, Jada. So where's this girl on a daily basis? You make these great connections that are like even above your level right now. I'm very impressed. So now our final prediction. Our last equation ties in a couple of things. We have two numbers in this last equation. We have a ×3 and a +2. We should all be able to predict by now what that +2 is going to do to our line. What's it going to do?
make it go up.
So we know our line should at least move up 2 units. Now what do you think that ×3 will do? Now we said multiplying times a fraction, like 1/2 or 1/3 or 1/8 or 2/3, anything smaller than 1 makes our line get flatter. But that 3 is definitely bigger than a fraction. So describe what you're doing with your hand there. What's going to do to my line? If it's not getting flatter, it's getting more what? More vertical, more steep. I like it. You use the better word, actually, vertical. So we have two predictions. That it should move up 2 squares, and this 3 might make it steeper or more vertical. Let's find out. Pick your final color for this part of the lesson. Let's go regular black. And let's make our table again and check and see what we get. So x, y, -1, 0, +1. So now it's 3 times x plus 2. What's 3 times -1? -3. Plus 2 in the positive? -1. What's 3 times 0? 0 plus 2? And our final one, what's 3 times 1? Plus 2. Let's graph that bad boy and see what we get. So our first point's at -1, -1. That's left 1, down 1 whole square. Our second point is at 0, 2. I don't go left or right, but I shoot straight up 2 squares.
What?
Be more specific. And then 1, 5 is right 1, up 5. Feel free to ask me a clarifying question. So connect these if you can, as best as you can. So our two predictions were, first of all, that it would move up 2 units on the y-axis. Is that true or false? Did it move up to 2?
Yeah.
So that +2, we had a transformation. Well, actually, it shifted 2 units up. Shifted 2 units up. So that prediction was right. And then our second prediction was it was going to be more vertical or more steep. Is that true? Yeah, that one shoots up really fast. So, and we'll say more steep. Actually, I'm going to use yours, like yours, but more vertical. That's actually the perfect way to say it. All right, so that's your notes for this lesson today. Let me go over your assignment now. So that way, in case, because I guarantee you that not only will the video help you guys remember this, but so many of you guys, when you get home, you forget what to do on the lesson. That's just a normal thing. So let me show you the iExcel for today and how it's going to work. All right, please listen. We're still on, and we're not done yet. All right, so for iExcel today, you're asked to find either the x or the y intercept. So on the board over here, I have some notes for you, or a little cheat sheet, so to speak.
Cheat sheet.
If they ask you to find the y-intercept, then make your x a 0 in the equation and solve for y. If they want the x-intercept, make your y a 0 and solve for x. So we'll take this first example that's on the screen. It says 10x plus y equals 0. And we're asked to find which intercept. So if I want to find the y-intercept, which letter or variable becomes a 0? So in your equation, replace the x with a 0. So I get 10 times 0 plus y equals 0. What's 10 times 0?
0.
So then what's all that I have left over? So y equals 0. So according to my math, the y-intercept should be 0. Hopefully we did this right. And I am wonderful. It's official. Peter said so. So now you guys have to treat me wonderfully. And that's what you can do for the rest of these. Let's try the next one. 6x plus y equals 6. We're asked to find the x-intercept. If you want the x-intercept, which letter do you make a 0? No, the y is always the opposite. So I make the y a 0. So I get 6 times x plus 0 equals 6. Does adding 0 do anything for you? Then I get 6 times x equals 6. X would have equal 1. You divide both sides by 6. You get x equals 1. So my x-intercept is at positive 1. Submit. And I'm super now. So you're going to do this for at least 10 questions until you get an 80. You can get fraction answers. So let's say you get something like 6 over 5 instead, like right here for your answer. Okay, that was 5x. Then you would type in 6 over 5. Do not give me decimals. Decimals mean you cheated with the calculator. So make sure you do not give me decimals. You give me the full whole number or improper fraction form. And that